No coastline, no tides. Across the flat agricultural land of the Mississippi Delta, more than 100,000 acres of still water sit in rectangular earthen ponds, each one a managed production unit. These ponds were not natural features. Farmers excavated them from former cotton and soybean fields. He engineered for water control and stocked by design. What looks quiet from the road is one of America's most concentrated freshwater aquaculture systems. Mississippi's pond network produces roughly half of all farm-raised catfish consumed in the United States. Now, this video traces the full system, from first fingerling placed in the water to the sealed box on a refrigerated truck. If this kind of operational detail is worth your time, subscribe and leave a like below. Tell us in the comments, did you know Delta ponds supply half of America's farmed catfish? The first feed truck is already on the levee. The Mississippi Delta sits in the northwest corner of the state, where flat alluvial terrain extends for hundreds of miles. Starting in the 1960s, farmers converted cotton fields to aquaculture ponds drawn by clay soils, a shallow water table, and mild winters. Grow-out ponds range from 10 to 20 acres, excavated to 4 to 5 feet deep with compacted earthen levees. Each pond is an independent unit, filled, stocked, monitored, and drained on its own schedule. Water enters through wells drawing from the Mississippi River Valley Alluvial Aquifer, one of the largest shallow groundwater systems in the central United States. Its mineral content and temperature profile sets the baseline condition for everything that follows. Levee roads connect every pond in the operation, wide enough for feed trucks and harvest machinery. Grain bins and equipment sheds sit at the field perimeter. The infrastructure is agricultural, built for function, not appearance. Water temperature governs the production calendar. Channel catfish grow actively between 65 and 90 degrees Fahrenheit. In winter, metabolic rates slow. Feeding stops and growth pauses until spring temperatures restart the cycle. Dissolved oxygen is the most critical daily variable in pond management. When levels drop below 5 milligrams per liter, fish show stress. Below 3, mortality risk escalates. Monitoring stations log oxygen readings through the night. Paddle wheel aerators are the primary oxygen delivery system. Positioned along the levee banks, their rotating paddles churn the surface, drawing atmospheric oxygen into the water column. Large ponds run 6 to 8 units nightly. Algae blooms regulate the oxygen cycle. Dense green water produces oxygen during daylight through photosynthesis, but consumes it at night. Managers assess bloom density using a Secchi disc lowered into the water. Fingerling production begins at dedicated hatchery facilities, not in the grow-out ponds. Broodfish, mature catfish selected for growth rate, gas feed conversion, and disease resistance, are held year-round in controlled tanks separate from the commercial cycle. Catfish do not scatter their eggs. A female deposits a dense egg mass inside a metal cylinder on the tank floor. The male fertilizes it and guards it. The hatchery staff collect egg masses within hours. Egg masses move to hatching troughs where mechanical paddles replicate the fanning motion a male parent performs in the wild. Incubation runs 7 to 10 days. Fungal contamination is the primary failure risk. Fry emerge at 1/2 inch and transfer to outdoor nursery ponds where algae blooms provide initial nutrition. When fingerlings reach 6 to 8 inches, 60 to 90 days later, they are graded for grow-out ponds. Fingerling hauling trucks carry insulated tanks with oxygen injection. Live transport demands constant attention. Water temperature must stay stable and oxygen monitored continuously. Mortality during transport is tracked and factored into stocking calculations. Stocking density is calculated per acre based on feed budgets and water quality capacity. A pond receives 5,000 to 8,000 fingerlings per acre. Those fish remain for 12 to 24 months before reaching market size. Feed delivery defines the daily rhythm. Floating pellets extruded from soybean meal, corn, and wheat are delivered by auger trucks traveling the levee network twice daily. Fish respond to surface pellets within minutes. Feeding runs once or twice daily, adjusted for water temperature. In summer, consumption is high and trucks run full routes. Pellets are formulated to stay buoyant long enough for fish to surface feed completely. Feed conversion ratios are tracked per pond weekly. The industry target is approximately 2 pounds of feed per pound of weight gained. Any deviation signals a problem, disease, water stress, or equipment failure, and triggers immediate investigation. Disease management runs alongside daily feeding. Enteric septicemia of catfish, caused by the bacterium Edwardsella ictaluri, is the most economically significant pathogen in the industry. So behavioral observation and daily mortality counts form the first layer of detection. Water quality sampling follows a structured weekly schedule. Field technicians collect samples from multiple depths across several ponds, testing for ammonia, nitrite, pH, and alkalinity. Here, results enter a farm record system tracking each pond's chemistry history separately. As fish approach market weight, typically 1 to 1.5 pounds, a sample seine is pulled across the pond. Weight and size distribution determine whether the pond meets harvest criteria. Taste testing is mandatory before harvest. Catfish are susceptible to off flavors caused by geosmin, a compound produced by certain algae in warm pond water. One off-flavor detection places the entire pond on hold. If off-flavor is confirmed, harvest delays until weekly tests show clean flavor. Here, water managers may drain and refill the pond to dilute concentrations. Delays can extend weeks, directly disrupting processing plant schedules. When flavor clears and size targets are met, the harvest order is placed. Arrival slots are pre-assigned. And fish must be processed the same day they leave the pond. The window is measured in hours. Harvest begins early morning before water temperatures rise. A seine net hundreds of feet long is deployed across the full width of the pond. Winch-equipped tractors on opposite levee banks begin the slow mechanical pull. As the seine draws closed, fish concentrate into a shrinking corridor. Aerators run at maximum output to maintain oxygen in the crowded mass. The full pull on a large pond takes 2 to 3 hours. At the harvest corner, a hydraulic dip net crane lifts batches from the compressed net directly into insulated live haul trucks. Each load carries 5,000 to 8,000 pounds of live catfish in aerated water. Live haul trucks depart immediately. Travel time is held to under 2 hours. Oxygen injection continues throughout. Fish condition at plant arrival, stress level, bruising, mortality rate, directly affects processing efficiency and final product quality. At the plant, trucks back into receiving bays. Fish transfer to indoor tanks through a pressurized pipe system that keeps them in water throughout. Time from pond to plant receiving tank is logged per truckload. Processing plants run high-volume daily schedules during the main harvest season from spring through late fall. Facilities process hundreds of thousands of pounds per week. Multiple shifts cover the full day with sanitation cycles between them. Fish enter the processing line through a mechanical stunning system before slaughter. The line moves continuously. Workers at fixed stations along the conveyor each perform one specific task. Heading, skinning, filleting, and trimming occur in sequence. Skinning machines remove the catfish hide in a single mechanical pass. The skin moves to byproduct processing, carrying value in secondary markets. Fillet yield from a market weight catfish runs 35 to 40% of live weight. Fillets and whole fish move through separate automated grading systems. Fillets are sorted by weight into size classes. Whole fish are graded for the retail market, sold to distributors serving regional grocery chains and restaurant accounts. USD. A inspection is embedded in the processing line. Federal inspectors verify product condition, temperature compliance, and sanitation throughout the shift. Each lot receives a code linking it to its originating pond, harvest date, and shift. After grading, fillets enter a chilling system where internal temperature must reach 34 degrees Fahrenheit before packaging is permitted. Chilled water baths and air chilling stages run in sequence. Non-compliant product is diverted and held. Packaging lines wrap chilled fillets in vacuum-sealed trays or bulk retail bags. Labels carry product weight, pack date, lot number, and country of origin. Federal rules require domestic farm-raised catfish to carry the USDA mark at retail. Sealed product moves to refrigerated staging areas. Pallets are built, wrapped, and tagged with routing information. A cold storage holds between 32 and 34 degrees. Dock doors stay closed between transfers to limit thermal gain. Refrigerated trucks depart within hours of packout. Distribution routes reach regional grocery chains, broadline food service distributors, and institutional accounts. A portion of product moves to secondary processors for value-added preparation, breading, marinating, or portioning before final packaging. The channel catfish, Ictalurus punctatus, is native to rivers across the central United States. So its shift from wild-caught species to farmed commodity took 4 decades of industry development beginning in the 1960s. Mississippi accounts for roughly 60% of total U.S. farm-raised catfish output. Alabama, Arkansas, and Texas follow. The concentration reflects clay soils, shallow aquifer access, and warm summers specific to the lower Mississippi Valley. The industry employs thousands of workers across pond operations, live haul transport, feed milling, and processing. Filleting rates are measured in units per minute per worker. Shifts run 6 days per week through the primary harvest season. Energy is a significant operating cost. Aerators run nightly across thousands of ponds in summer. Feed mills and processing plants chill, pump, and refrigerate at industrial volume. Combined power loads approach a small manufacturing facility. Between cycles, ponds undergo intentional drawdown, a partial or complete drain. This consolidates bottom sediment, exposes the floor to sunlight and air, and reduces pathogen populations. A dried pond floor can be restocked within weeks. Integrated operations vertically consolidate fingerling production, grow-out feed manufacturing, and processing under one ownership structure. This controls input costs, stabilizes processing line supply, and allows production adjustments across the full system in response to market pricing. The industry encountered import competition in the early 2000s when Vietnamese Pangasius entered U.S. retail at lower prices. Federal labeling rules were revised to restrict the term catfish to native Ictaluridae family members on retail packaging. Domestic farm-raised catfish holds a stable position as a southern regional staple. School lunch programs, cafeteria accounts, and casual dining provide a predictable volume baseline that supports steady processing plant utilization through the season. The last trucks leave the dock. The plant enters its overnight sanitation cycle, floors scrubbed, lines disinfected. Back in the Delta, grow-out ponds carry the next population. Aerators turn, feed schedules reset, the production calendar advances. Sealed boxes move along refrigerated routes to grocery and food service accounts. The pond surface in the Delta settles to stillness. The levee roads are quiet. This system runs in cycles measured not in days, but in seasons.